Section 3.4, we're continuing to look at geometric series, geometric progressions, and we're going to look at geometric series. So by this point in the chapter, you know that a series means that we're taking the terms of the sequence or the progression and we're adding them up as we go along. And you're perhaps not surprised to learn that this is what we're going to do then with geometric series. Like with arithmetic series, we need a formula. And once we've got a formula, we're going to be able to use it for all the same things. So once we know that Sn for a geometric series is such and such, then we can answer questions like add up the first 10 terms of this sequence, and you know how many terms you need to add up to exceed a certain number. So I'm not going to go through those examples because they work the same way as they've done previously. So if you're stuck on the examples or the questions in the exercise, go back and check you understand the rest of the chapter and understand the way that Sn works, the way that Un works, and the idea of just using the formulas to make those things happen. And now this time we're just going to use a different formula because it's a different kind of sequence. You just need to say, well, that is a geometric series, so I'm going to use the formula for geometric series. What we need to know then is how do we sum the first few terms of a geometric series. And there's a formula for it, and that formula is one that, again, you need to know for the exam. And the derivation of that formula, the proof of why this formula works, is one that you need to know for the exam. So make sure you have a nice way of writing this down. So the sum to n terms is the first term plus the second term plus the third term, plus the fourth term, AR, can't speak and write at the same time, plus everything up to AR to the n minus 1. So that's the first n terms. Here's the clever bit. The thing you wouldn't have thought of unless you've revised it or seen it before is take that lot and times it by r. Now what happens when we times it by r? Well, a becomes a times r, and I'm going to write it here. I'm just going to leave a little gap. AR becomes AR squared, and AR squared times r becomes AR cubed, and so on. And when I times the last term by r, I get AR to the n. Okay? So you can see these things line up. They're basically the same in both lists. So if I do this one, take away this one, no, there's a clever way to do this actually. We'll do the first one, with the first row, take away the second row. Equation number 1, equation number 2, because that gives us the formula in the usual form. So equation 1, take away equation 2. If you do it the other way around, it works, but the formula doesn't look quite right. It doesn't look exactly the way that they want it to look. So if you get used to doing 1, take away 2, which sort of perhaps feels a bit wrong, but it works nicely. We get Sn take away r lots of Sn on the left-hand side. And on the right-hand side, well, we get A, then AR take away AR squared take away AR squared, AR cubed take away AR cubed. All of these things cancel out, and what we get left with is A, and then minus AR to the n on this side. Factorise on this side, factorise on this side, and here is our formula. The sum to n terms is a times 1 minus r to the n over 1 minus r. Okay? If we look at this, then they're going to give you two of these letters. They're going to give you a and r and ask you to find n, or they're going to give you a and n and ask you to find r, or n and r and ask you to find a, or they might give you Sn and, you get the idea. We're going to use it like a formula. This time, if they're asking us to find how many terms, they tell us the sum of the first few terms is this number, they tell us a and they tell us r, and they're asking us to find the n. Have you noticed the n is the index? So we might need to combine this with our logarithms knowledge now to solve those equations if we get one. But that shouldn't be too much of a problem. If it is, then go back and revise the logarithms. And I think that's everything in this section. Yes, it is 3.4 done.